Now you've extracted all of the data, the last thing that you need to do is assemble it all together in a file. What you're looking for is one row for each of the different studies, and the information that you need to have in the columns are author, the year that it was carried out, ME, which is the mean of the experimental, the mean of the treated group, SE, that is the standard deviation of the experimental or treated group, NE, the number of that are in the experimental or treated group, then the same for the control. So the mean for the control, the standard deviation for the control, and the number of participants in the control. Here they're all done. I think I need to reformat these cells because they've truncated, but this is just a small thing to a general number. Okay. Maybe they haven't. Maybe that is actually 2.00. Looks like it is. Fine. Once you've got all your data in that format, and I usually do it in Excel, it doesn't matter what program you choose to do it in. It's saved as an Excel file, but I'd sooner save it as a CSV file, so a comma separated variable file. This is a plain text file. If I open this file now, which will open in Notepad++, you can see, well, this has used semicolons between each of the sections rather than actually commas between comma separated variables. So you've got author, year, ME, SC, NE, and so on. And when it's just as text like this, it makes it a lot easier to handle by multiple different programs. If I now start SPSS, I can carry out a simple analysis there. I don't want any of those particular things. Oops. I want to just use SPSS from the start. So now I've got SPSS empty and it's not got any data files open in it. So I want to import the data using a CSV file, meta-analysis data.csv. First line contains variable names, it definitely does. Decimal symbol is going to be a period. Text qualifier, double quote, if there was any, there isn't. Delimiter is a semicolon, which is correctly figured out, and go OK. They had to do a slight change in the way the columns are labelled because NE has a specific meaning inside SPSS. Now that column has been relabeled here. You can check the status of each of the different columns. To be honest, in variable view, everything apart from the first column should be a scalar variable because they're all numeric rather than nominal. It doesn't make a huge difference, but definitely you want to see all of those, the means and the standard errors, standard deviations, all as numericals. Year can be left as a nominal, I suppose. Well, it's ordinal. Right, so the data is in. I can save that data set. I can save it as meta-analysis.sav. I'm going to replace one that I did before. As I'm using this in Spain, it's put commas in SPSS because it's taken the Windows default. Depending on how your system is set up, it will look different and it should have decimal places. So I've got the program running in English, but it sometimes takes things from the operating system, which is telling me that I am geographically in Spain and should be using commas instead of decimal places. To carry out a meta-analysis, you go to Analyze, Meta-analysis. It's got continuous outcomes, and we're going to do it as raw data because it is raw data. Then you need to look and match the columns of your data to those within the program. The study size for the treatment group is NE. The mean for the treatment group is ME, and the standard deviation for the treatment group is SE. The study size for the control group is NC. The mean for the control group is MC, and the standard deviation is SC. The study ID is author. And then it's got the ways you can calculate the effect size. Now I'm going to start with using an unstandardized mean differences. So the raw data itself, not transforming it using Cohen's d or any of the other measures of effect size. You can start in a fixed effects model, but I'm going to start in the random effects model as it suggests. Now you need to pick your plots. The plots you can do are forest plots, bubble plots, funnel plots, scale brace plots. I'm doing something simple this time, so I'm going to just stick on the forest plot. What do I wish to display in columns? I want the effect size, standard error, confidence interval, limits, p-values and weights. I want to see reference lines for the overall effect size and the null effect size, and tests for homogeneity and heterogeneity. The other plot that I'm going to plot is the funnel plot to look at potential bias in the publications to see whether they're publishing positive and negative results. When we were extracting the data, we saw that one of the results is definitely strongly negative, so I'm hopeful that the funnel plot will show a reasonable distribution of results. That is okay, and continue. I will not do the bubble and Galbraith plot this time. And go OK. Here is the result of the meta-analysis. Here, this grey line is the zero effect line. The red diamond is the summary of the result, and the red dashed line is the mean effect. Now if you look at the effects here, it's 0.62, so that's how much your VAS is changing dependent on the treatment summarized from that set of data. Here is the negative one. Here are the positive ones, including Cerezo Teles, which was the first one, and the VAS study. Cerezo Teles had some problems with participants dropping out. VAS seems more reliable. And this is the difference between placebo and effect. Now, for Cerezo Teles, the placebo was also not sham acupuncture compared to the others, which are more on sham acupuncture. If I was to compare, instead of against the placebo, against no treatment, then the effect size would be much larger. This is just the extra effect that you're getting from the acupuncture compared to the placebo, not compared to nothing. You can see there are different weightings here, and if you look down at the heterogeneity, it's fairly well, with the random effects model, it's not actually too bad. It's not 100% and really awful. It's still not great, so there is a fair amount of heterogeneity. As you can see, a large amount of studies here that are very similar to each other. Then there's these two, VAS and Cerezo Teles, and the Sahin one, which gave the negative result. Looking at the funnel plot, there is a nice scatter both sides of the mean difference line. That means that the research is including as many negative results as positive results, and that's good. You can see the ones that are outside the usual range, so they're unusual. So this is those two very positive papers, and this is the one very negative paper. But in general, apart from those, there is a concentration as the size of the sample gets larger to coming towards that point. So most of the results sit within the triangle, which is a comforting result.